Hello, my name is Dmitry Polyakovsky. I'm excited to be back at Valkey conference to talk about Valkey. And this time around, I'm going to present on how we can customize Valkey with Rust. So I've used Valkey and Redis for many years. And my day job, I'm a tech lead for the Oracle Cloud Caching team. We offer managed Redis and Valkey. Check it out if you're interested. But I'm also the maintainer for the Valkey module Rust SDK. Quick survey. How many people have used cache as a primary Redis Valkey use case? Message broker, session store, leaderboard. Anybody got really cool use cases, like actually using Valkey as a primary database? Done it? Yeah, me too. It requires a little bit of work. All right, another survey. How many people have built modules in C? C++? All right. Rust? All right. So in this presentation, we're going to focus on why should we build modules in Rust. We're going to talk about how the Valkey modules Rust SDK can help you in that. And last, I'm going to demo an example of a job queue that I built using Valkey module and talk about some of the lessons learned from that. So why should we build modules in Rust? Well, first, let's think about what it takes to build a module, and let's deep dive into the C code. Oh, this is going to be tricky. OK. All right, so if you open Valkey repo, you'll find the Valkey module.h file. It's about 2,200 lines of code. Module.c file, it's about 14,000 lines of code. So if that sounds a little intimidating, I recommend starting with examples. So for example, here's the hello type module, which allows you to create a custom Valkey data type. And what you will find in these modules is that this Valkey module unload, that's required. There's also Valkey module create command, which creates custom command. And there's things like Valkey module not used, error, etc. And also you can look at the tests. So here are the test modules code. And this is a really good place to get started to understand some of the basics, even though you might be not using C but Rust to build your module. Okay. So why should we build modules in Rust? Well, I like the idea of memory safety. Anybody experience a memory leak? Well, this is not just a memory leak in inconvenience. It can actually be a security vulnerability. We don't have time, but those who are interested, Google memory safety languages. There's all kinds of emphasis on that, including white papers from various three-letter government agencies, how you should use memory safe languages. And Rust is such a language, it prevents a lot of memory safety problems. Another reason I like Valkey, to build Valkey modules in Rust and program in Rust in general is the ecosystem. Cargo is a really nice tool for build management, dependency management, unit testing. The crates.io, crates are Rust libraries. It's a very large repository of various packages, saves you time. And of course, the Valkey modules Rust SDK helps you integrate with the Valkey C code. Are there any questions so far? All right, so let's deep dive into the Rust SDK. So we forked Redis modules Rust SDK about a year and a half ago when the Valkey Redis fork happened. And we started adding some features to bring it up to the same level as the underlying C module APIs. So let's jump into examples, actually, to talk through it. Oops, not this repo. OK. So the place I like to start is examples. That's actually a standard thing for Rust libraries. You have examples on how to do things. So for example, here's an example of how to implement client. So this is something we added to the SDK. And we added a lot of really nice helper methods, which were supported by the underlying C code. And shit. OK, this is going to be tricky. Is there a clip-on mic by any chance? Oh, this works? OK, let's see if I can. Can you hear me now? All right, there's always at least one glitch. Can you hear? Awesome. Perfect. I will try to remember to take the other mic when I'm walking around. OK. Can you guys hear me? All right. We'll make it work. All right, so if you go to the example and let's say there's a method on how to get client ID, and it calls the underlying context, and context, you'll see that a lot in various examples here, is that basically it's a pretty important part. But you can see here that it's simply wrapping the underlying Redis module get client ID, and you don't need to write any of this ugly unsafe in your code and justify it in your pull request. You just say ctx.get client ID, just like how I did it in the example. And all the ugliness is abstracted. There's also other methods to get client name, get client username, client info is very useful, and so on. And these are basically created when we were building various Rust modules at Oracle Cloud. We kept finding these things. We first were just writing code ourselves, and then we said, why don't we just push it upstream and make our own and everybody else's life a little bit easier. So here's the, for example, we even added this config get, which allows you to simply just get configurations. It literally is a wrapper around this one. So it's just a little wrapper around a call to a config get, and it just does a little bit of formatting. And then we added this thing to deauthenticate and close client. So we basically just went through, like I said, the underlying Rust, the underlying C, and you can actually see that in this bindings that is generated from the Valkey module H file. Okay, so that's the client functionality. And if folks have questions, just feel free to raise your hand and ask. Okay. Another thing that we really like is event handlers. Anybody use event handlers? Okay, so what you can do with event handlers, and there are examples in server events. Already had several event handlers, but we added some more. For example, there's this key event handler. When key is deleted, evicted, overwritten, or expired, you can now write your own custom code to execute automatically. And when client changed event handler, happens for client connect and disconnect. So this is literally, you can copy and paste this code. But keep in mind that this actually comes from the Valkey RS macros crate, which is a separate crate underneath the main. You'll see it in the same GitHub repo. But all you have to do in your code is just, oops, that didn't work. Just put this little macro, and just then you match a client event and do something special that you need for client disconnect or client connect. We added keys, we added events also for shutdown and for persistence event handler. So let's say you want to fire a custom code when RDB start, AOF start, events happen. It's a very nice abstraction. Okay, filters. Has anybody tried using filters? Okay, so filters are useful and powerful and a little dangerous. Basically, they run before every single command executes. So you want to be very careful not to cause negative performance. But how can you use them is that we added functionality to the SDK to make it much simpler. So we built this context filter, a bunch of methods for context. And here you can see there's example filter 1 and filter 2. And again, you can have multiple filters defined in different libraries, different modules, working side by side. There won't be any conflict. But obviously the code will run, and you have to be careful not to have like some kind of a, let's say one filter does something to a command and another filter does something else. So you have to just think about the order in which they execute, and that is in the order in which they are defined, and then the order in which the modules are loaded. So for example, here I have a module called filter 1, and then I have a module filter 2. So here in the module filter 1, I have a set filter. So let's deep dive in that a little bit. So you can see here that I create a command filter context, which is different than the regular context. I then can access arguments. And here, I grab the very first argument and I say, is this command set? Why? Because this is a filter that I apply only to command set. So you want this code to execute as quickly as possible. So first I'm checking for the args count, is it's 3, and that's a common pattern in set key value. And then I check is the first command set. And if it's not, I exit this code because, as I said, filters run before every command. So if you run delete, get, this filter will execute, so you want to get out as quickly as possible. Then I grab all arguments, and again, we built some nice helper methods around that, so you can just double-click on it and look at the actual context methods. It's in the filter.rs file. And then I say, look, hey, let's grab a key, let's grab a value, let's log it just because it's useful for debugging. Again, be very careful with logging and filters because, as I mentioned, it's going to fire on every single command. And then I decided to delete the second argument. And then I decided to insert another argument in its place. And then I decided to replace the third argument. So I literally took, so whatever basically you do, is if you say set foo bar, it's going to replace it with set new key, new value. Very silly example. But in addition to modifying actual arguments, I could modify a command. So instead of having a set, I can create my own command called Dmitry set and actually replace the 0 argument, the command. So I will essentially hijack the set command and do something completely different. And that can be useful for things like authentication. If you're not using Redis or Valkey 7.2, where there is a useful callback that was implemented for basically, at Oracle, we implemented custom authentication to be able to use the Oracle-issued identity tokens. And what we did is we implemented a filter that essentially overrides the auth command with our own custom auth. And then there we do the check. And if you are using the appropriate token, we do the validation. If you're doing the password, we just kind of call the regular auth command. So again, filters are powerful, but could be a little dangerous. Any questions so far about filters? Yes? Yeah, absolutely. The question was, can you add any command? And it's not about adding a command, it's about applying a filter to specific commands. So here this filter is applied to set command. I could have applied this filter to get. I could hijack a get command and run my own command instead of it and return whatever I want. Yes? Sorry, you're getting a microphone. Let's do that.
I was asking if you could add a new command like Dmitry set.
Oh, of course, yeah.
That you send from the client.
Yes.
And you filter and you apply what it's supposed to do this way.
Yes, you can apply a filter to a custom command, Dmitry said, but it probably wouldn't make sense because if I'm controlling the command, if Dmitry said, I would just write the custom logic there. Versus filter, I would say, is more useful toward existing commands or a command from another module where you don't control the source code or you don't want to touch the source code. But yes, theoretically, I could have a command Dmitry set and then filter only for Dmitry set. Like I said, there will be a greater performance impact with that approach versus just modifying my custom command. Any other questions? And Kyle has the mic if anybody needs it. Okay, so you can see here that in addition to Dmitry, do the set function, I created 2 other filters, and I don't do anything there. Now, to register filters, you can do it the easy way, using the macro, where you see I can just define them here. It's new set filter, or you can do it the hard way. And the hard way requires you to init and deinit, which is when the module is loaded and unloaded. You just call this register command filter. And then you have to do a little bit more checking. So under the hood, if you double click on that, you will see that, again, this is an extension of the context where we added 2 new functions, register and unregister command filter. But to make it easy, if you actually drill down on a Valkey module macro, you will see that there's a code that actually takes advantage of this. Basically, this. So again, to keep things simple, just use the macro, specify an array of filters, and you also specify the flag for each filter, but it's pretty easy, and you just have to then focus on writing the filter logic. Be careful, as I said, potential performance impact. Okay, how many of you worried about making sure you're running the right version of Valkey or Redis when you load a module? Thank you, Madeline. I certainly worry about that. So there is actually 2 existing hooks, init and deinit, right? Oops, preload. The problem with init, even though it runs at module loading, it runs at the very end of it. And you can drill down into the Valkey module macro and see it. And by that point, for example, it already finished initializing the commands and data types and other things. And sometimes that's not what you want. You want to just stop at the very beginning. So we created a new hook called preload, and it happens before loading. And the most useful thing I can think of doing in preload is just verifying the version. So here, you can see that I'm calling context get server version. That's the existing functionality. And if it's not whatever the minimum version I support, I can just stop the execution and not load the module, return status error. So it's very similar to load and to init and deinit, initialize and deinitialize, but it just fires at a different time. We thought about doing afterload, but I really couldn't think of any practical use case, so there's just preload. There is no afterload. How many of you created custom configurations for your Valkey or Redis modules? You know, like config, get, like instead of max memory, you want to store some kind of a custom attribute. Well, the thing is that you're opening a lot of power, you're giving a lot of power to your users. And maybe you want to do a little bit of validation to make sure that whatever that string is doesn't contain certain invalid value, or maybe if it's a numeric configuration, it doesn't exceed a certain, or maybe enum, like, I don't know. You need some custom validation, right? Okay, so you'll find an example of that now in custom configuration. It's an optional parameter. And what you do is you basically specify this optional validation. And the validation is here, for example, it will reject I64 validation if its value is 123. You can also have a custom validation on string. If the value is reject value, it'll reject it. So pretty simple code. You don't have to use it. But again, it's a nice to have feature. How many of you have passed custom configuration to module on a module load command or know that it's possible? It is possible. Madeline, you can just raise your hand for every single question probably. So it's a default. I get it. OK, so basically when you do module load, you give it a path to the .so file, and then you can pass a bunch of arguments. And by default, it'll actually ignore them, but you could do something with them. So I'll show you another interesting example. So this is a module that allows me to execute custom cron functions leveraging the server cron process. Server cron by default runs 10 times a second. It can be configured, so don't make that assumption. Double check it if you're building business logic for that. But in production, you might want to have one schedule. And versus in local development environment, you want to run something much more frequently. I personally got tired of just hacking my code for local dev testing, so I decided to have a concept of environment config. And the same is present in many other application frameworks. So basically, you have certain configurations that are specific to your local dev environment versus different in production or different in integration cloud environment. So what you do is you basically pass a parameter. When you do a module load, you say, let's say, dev. Then in this initializer, which we have covered before, we grab this argument and call it env name. If the nothing passed, we just default to blank string. And then we try to load the appropriate env config. Essentially, it's just, well, this is actually a wrapper around this struct. But in this struct, I defined two configuration options. One is called, they're both strings. And one is a cron expression I'm going to use for my function 1 and function 2. And another one is a cron expression for function 3. Doesn't matter what it is. It can be anything. It could be a URL that you're going to query or whatever, or credentials to some third-party API. But basically, what I'm doing here is I'm specifying slightly different cron frequencies. So for function 1, function 2, they run every 5 seconds. Function 3 runs every 10 seconds. And in production, it's 15 seconds and 30 seconds. And then in this cron tab, I'm actually creating this whole, again, at the end of the day, it's just a hash map, right? Which maps string to a vector. So string is the cron tab expression with some validation on it. Vector is just the functions which I'm going to execute. So I just created a cron tab. Then I'm running function 1 and function 2 on a 1 interval, and function 3 on a different schedule. And you can run them every few seconds, every few minutes, every few hours. It's just like any other cron tab. Be careful a little bit, because if you make it very slow, that could block the main thread. So if you're really concerned about performance, either spin up a background thread inside your function when you're actually running the cron process, or later in my presentation, I will show you how to just run a background thread and not bother leveraging this server cron process. And then in your background thread, you can just implement appropriate sleep. Okay, so, oh yeah, and basically we're using this cron event handler, which was a pre-existing functionality, and it's just a macro that's provided by the SDK. Oops. Okay, so we talked about the cron tab. Okay, how many of you like writing unit tests? Oh, come on. Okay, how many, let me rephrase it. How many of you have been bitten by a bug in production and you said to yourself, oh, if only I had unit tested that code, it would have saved me so much time. Okay, that has to be, come on, if nobody, somebody's not raising their hand, you guys are lying. Okay. So there's a little caveat with this unit testing because there's some memory allocation stuff that happens. So what we did is we built, actually it was one of the first things we added to the SDK, is a system alloc fee, enable system alloc. So it's documented on the GitHub page because we felt it was important to kind of like make everybody aware of it. So it's a feature flag for unit testing when your Valkey or Redis engine is not running. So it basically uses system alloc instead of the Valkey owns memory allocation stuff. So just configure it. If you're interested, just grab for it. You'll find a place in here. I'll show it to you. So, like, this is all we added. It's just a feature flag, sort of. Otherwise, if you don't have it enabled, it'll go here. So, unit tests are good. Need system allocation. Use it. And another really important thing to us is still maintaining Redis module compatibility. So again, at Oracle Cloud, we run a lot of Redis servers on our customers' behalf, so we always write the code to be backwards compatible as much as we can. I mean, there are certain things you cannot do. If, like, for example, Valkey 8 introduces certain features that are simply not there, right? You will still have to be mindful of that. But if you're not taking advantage, if you don't need those, you can write the code in such a way that it'll work with both Redis and Valkey. And for that, you have to specify this use Redis module API flag. And we explain that right here. For those of you who want more examples besides what's in a crate, please check out Valkey Bloom and Valkey LDAP. Creator of Valkey LDAP is sitting right here. So there's some really useful patterns that you can learn from. And for the future of development, we're thinking of more callback support. For example, there's auth callbacks that we do support, but we want to just add more. And another really important thing that I personally want to introduce is that mock context. So you saw that context object in a bunch of places. Well, there's a context dummy present in the SDK, but it doesn't do hardly anything. So what I want to do is I want to build a context mock, which will have mock responses to all the usual context calls, and then you'll be able to test your commands by passing this mock context outside of the Valkey process and do more unit testing. And there's another interesting thing. So the filters that I mentioned, if you paid close attention, I wasn't actually using the context. I was using a different context. Let me show you. It's a command filter context, which is very different. So I want to figure out how to actually introduce support for the full context in filters so you can do more stuff then. And here are the contributors who made all these changes, so just want to give them credit. Are there any questions about the SDK so far? Anybody? Yes.
Hey, thanks for the presentation. It was good.
It's not done yet.
Oh.
Yeah. The best part is yet to come.
Why do we need different contexts? I mean,
In the filter?
Yeah, like for the filter, for the unit, yeah, like, show us several different contexts during the presentation. I wonder why we need more than one.
Great question. I'm still trying to figure that out. I wish it was simpler. Did I mention that we forked the Rust SDK? Madeline, do you have any insights?
Well, I think they just have different pieces of information.
Yes.
One of the things is so there's the top level context, which we want to pass around, and you can do specific things like when you have a Redis context or now a Valkey context. By the way, you should update this to say Valkey.
Where?
Everywhere. I keep seeing
that's-
Redis. Not important.
That's for the backwards compatibility stuff.
You can't. Not important.
well,
So
yes.
the main context is supposed to be blocking on the main Valkey thread.
Yes.
So anything that's not that is a subset and like more specific. Also for type checking, if you just have a very generic context, you can have more. You can have runtime failures where if you have very specific types for what operations you can do, you get type checking.
Yeah, there's actually about 4 different context things. So yeah, it is a little confusing. I acknowledge that. Other questions? Nobody? All right. Now on to the best part of the demo, in my opinion. Okay. How many of you have used job queues, message brokers? How many have used Redis or Valkey as a job queue? Anybody use a client library? Or just did you write everything yourself? Ourselves. Respect. That's a lot of work. Anybody else? Anybody use the client libraries in Ruby? There's a really good one called Sidekick. In Python, there's RQ. In other languages, there's other ones. And guess what? Oops, I didn't mean to go this far. The problem with doing so much in the client library is it gives a very different user experience to different programmers. And the client library has to do a lot more work. It has to use the underlying Valkey data structures. It typically uses lists for actually managing the jobs. But sometimes they will serialize the entire payload into each item in the list. Sometimes they will use hash maps to store the actual payload and only store like some kind of unique ID in the list. It'll use hash maps also for aggregating certain statistics about queues. It'll use sorted sets for executing delayed jobs, and so on and so forth. And I haven't actually found a library that quite had everything I wanted. For example, a very important concept with queues is a guarantee of at least once delivery. Meaning, with a basic Valkey list, once the client library pops the item off the list, it's gone as far as the Valkey is concerned. So if you want to implement at least once delivery, you have to do something in the client where you'll take it from the list and you'll put it somewhere else. Maybe it's going to be in a hash map or sorted set, right? And then the queue has to kind of keep hold of it until a client either explicitly acknowledges that it completed, and then the queue will, yep, now I'll delete permanently this message. Or a client can also ask for more time, extend the particular message. And the queue has to keep track of how many maximum attempts there have been to deliver it. Because if a client never acknowledges it, after a certain amount of time, the queue will say, I never received acknowledgement for this message. I will make this message available to another worker, right? And after it exceeds those maximum delivery attempts, the queue should say, you know what? I had 5 attempts, and it failed. Nobody has ever acknowledged completing this message. There must be something wrong with this message. I'm going to move it to a DL queue, or dead letter queue. And I'm going to keep it there for a period of time, giving my operator time to analyze this information, maybe fix the bug, maybe re-queue the message. You can actually move messages from DL queue back to the main queue for reprocessing, hopefully after either fixing the code or fixing whatever third-party API you were trying to access. And there's also, like I said, the concept of delayed queue, where you can say, please execute this message in the near future. And sometimes that near future could theoretically be years from now. But, not a good, I agree, it's not a practical use case. But anyway, so those are kind of like the features that I really liked about queues. And first, I never found a library that quite did all of that. And third, I said if I were to build such a library in one language, it wouldn't really help developers in other languages. So I decided to build a module that encapsulated all these things. And to do that, I built a custom data type, and that required a custom struct. Okay. So here's a module that I built. I called it Valq. And I created a data type called ValQType. And then I created a struct I named it also ValQType. And you can see it's a pretty complicated struct. It's not just like one string. So I have a name of a queue, I have the ID sequence, and that applies to each message. So every time you push a message to a queue, it'll increment it. So this is how I can identify uniquely message within a queue. And by the way, you can have multiple queues within the system. Again, there's that visibility timeout, which has a default setting for each queue. But there's also min and max validations that I implemented. There's a maximum delivery attempt. Oh, wow, running out of time, shoot. Okay, I'll try to speed up. Okay, and like I said, the retention period. And then comes the more complex data structures. There's the vector of messages, there's a DLQ vector of messages, and there's delayed messages. So Valkey message is another struct. And at the end of the day, again, I'll make this code available. The code is available on GitHub, by the way, and anybody just ask me, I'll give you the repo. These are just structs. So if you can write basic Rust code, you can write these and you can unit test them. And I create a struct. It has a few attributes. And then I create implementation for the struct, which is how I can define methods in Rust. And then I can unit test the hell out of these methods. I don't even have to worry about I don't even have to think about the fact that this is going to run inside Valkey. It's just a piece of Rust code with some tests. Then I have this, like I said, enumerator of queue type, which is, like I said, there's DLQ, delayed queue, and main queue. Again, nice unit tests. Then I have a completely separate structure for delayed messages. And think of this data structure as essentially a sorted set. So I have a concept of a score, which is a map, which is a corresponding map of unique messages. And then I have members, which each of the messages has a score. So this way I can look up either by specific member, or I can look up things by specific score. And score in this case is a timestamp. And like I said, then I have some methods like to insert, remove, and check if ready to process, meaning is the score less than a current time. So for my data type, for the I actually implemented U64. And I checked, and it basically gives me ability to schedule messages up to 500 billion years into the future. I thought about doing U32, but then I said, year 2038 is a little too close. So I think 500 billion years is sufficient. Anyway, okay, so once I created these structs, and the next question is that, well, how the heck do I persist them? Because, again, Valkey has ability to persist to RDB files. Well, that also required a little bit of thinking, but I think I found a good pattern. So again, I create this static val queue type, which is how the data type is registered. And I defined, first of all, the free. Free is really important, by the way. If you don't even care about persisting to disk, but you don't define free, and then you delete the key, custom data type key, Valkey will crash. So define free. But here is where I just convert this to a box to deallocate memory. But here I also created something else, and that is I wanted to create a kind of like a global wrapper of all of the queues that I created. So I know how many queues exist in the system, because in addition to these queues, I may have just regular strings or hash maps for caching or whatever. And I created a global wrapper, and inside this free, I actually remove values from there appropriately. And I insert values in there when I create a queue. And then I created functions to do auxiliary load and save. And that is how I persist these data structures. In this case, it's only global queue list. That's only one. But think of the custom data, right? You're going to have your custom keys. In my case, it's a queue, but it could be a JSON. It could be indexes for the Valkey search. So those are going to be individual keys. But what if you wanted to know how many Valkey search indexes you have in your Valkey server? Or in this case, how many queues you created in your Valkey server. So that's stored outside of a key, and it is persisted via auxiliary save and load. For RDB save and load, so there's RDB save. So depending on what you're saving, you basically have 4 helper methods. Save string, save like basically string, float, signed and unsigned integers. And there's save and load features for both of them. So if you're saving just a string, it's pretty easy. You just save it as a string. However, if you're saving, let's say, messages, which is a vector DQ, right? So there's multiple messages. So what you do is you first have to save the size of that queue. So if you have 100 messages in a queue, it's first going to save 100. Then it's going to loop through all the messages in the queue and save each one. In this case, it's going to be a string. Here. Save each message. And then when you load data, you have to go in the same order. So RDB load, and again, I kind of like made this code a little extra verbose, but if you want to follow the pattern, I think the comments here will be very helpful. So load works the same way, right? When you're loading messages, you know that you first save the size. So you're going to get the size, 100, and then you loop through the next 100 entries in the RDB file, and you know that it's the next 100 messages. And that's how you load it back from the RDB file into memory. Are there any questions about that? Okay, cool. So again, you basically, my very complex struct, which is a combination of other structs, again, I just walk through it and I very methodically save and load all the individual attributes. If you want to start simple, just create a struct with like one attribute called data, make it a string, and then just do a save string and then load string. And then add another attribute, let's say integer, whatever, save that and load that. And then add something more complex like a vector, in which case you will need to, again, save the size of the vector and then save each item in the vector. Okay, so now how do we use these things? Well, I created a bunch of commands. Right? And these are just standard Valkey commands. It's lots of examples in the SDK on it. So I created commands to create, delete, list, purge, and update queues. And then I created commands to push, pop, extend, and acknowledge messages. So let me do a quick demo. Okay. So running Valkey server here, the module loaded. Okay. Oops. There are no queues created yet. I now created 2 queues. I pushed 2 messages in the first queue. I can now call info command, and I see that I have no delayed messages, no DLQ messages, ID sequence, meaning the current message is 2. The default configuration is 5 maximum delivery attempts. There are 2 messages, and if I, for example, if I push, so now I pushed a message and I specified an optional parameter of 100 seconds, so meaning it's going to go into the delayed messages. So in 100 seconds, if I do a pop, it's going to become available. And until then, it's going to sit in the queue. So let's do a pop. Okay, so I popped the first 2 messages. Remember, the third one is still sitting there because it hasn't been 100 seconds yet. But remember, I have to acknowledge these messages. Otherwise, in the default of, let's see, 30 seconds, they will become available for reprocessing because the queue is going to assume that I didn't succeed as the consumer. So let me acknowledge this. And you acknowledge by ID. Okay, cool. Okay, so again, we see that there's still that one message there. So let's try to extend it. Maybe I need more time. Oops. Oh, I need to ask for, I'm going to ask for 100 more seconds to complete the message. So now let's say I want to purge the queue. No problem. Everything's gone. And if I now check information on the queue, okay. So you can see how I was able to build these commands. And it wasn't that much code, actually, to build the commands. I did a lot of validation, but you could be a little bit, less careful. So another pattern I adapted here is that I really wanted to unit test this code. So what I did is I basically created command, and then I abstracted as much code as possible that didn't require the context into a separate handler method. So basically here I just open the key, get the value out of it, and pass it on here. So I can unit test the handler method, but without having the proper context, I cannot unit test the command. Another thing you have to keep in mind is that replication. Right? We want data to be replicated. So how do we do that? Well, we don't replicate data. We replicate commands. So what I did is I added this helper method, and what it does is it actually executes replicate verbatim. But you don't want to replicate for every single command, and you don't want to be able to execute every type of command on primary or replica servers. So here, basically, this command, this check, well, it's only applicable to write commands that modify the state, creating queues, pushing and popping messages, deleting queues. But for example, list or info, they don't change the state, right? So those can be executed either on primary or replicas, but you don't want to pop a message over a replica or delete a message or create a queue on a replica. So this code basically prevents that, right? So it basically says, hey, are you read-only and you're not replicated, it will reply with an error. All right.
Dmitry,
Yes.
we have 5 minutes remaining. Do you want to
Okay.
do any final questions?
Okay, super quick on the background thread. So remember that retention period thing that I mentioned? So how would we move messages from DLQ just into garbage, purging it permanently? So I created a helper method that basically runs. Why is it not loading? Ah, here it is. And it runs via the background thread that I initialize in my init method. There. All right. I think that's about it, and I do want to give some time for questions. Either everybody understands everything I just explained, or people are just intimidated to ask. Kyle, do you have any questions?
I don't have any questions.
Seriously? All right.
Okay,
Question,
okay.
thank you.
Deem.
All right. Believe me, standing here and nobody wants to ask questions, you're thinking, am I naked?
Yeah, first of all, very impressive. Like
Thank you.
total customization. Yeah, looks impressive. And my question is like, if I understand correctly what you showed us, you basically implemented everything by yourself, right?
Yes.
The data structure from A to Z.
Yes.
Valkey actually has the messages capabilities, right? Of course.
List. Yes.
No list. The Asaf, help me up here. The not pops up. There's the mechanism.
Streams?
Right.
Okay, yes.
Thank you. So there are some similarities. Of course,
Yes.
they're missing a lot of functionality. But my question is, was it an option to like reuse it somehow, to use it at the base times data structure and like add stuff, or it was not an option?
Well, okay, so it was possible, absolutely. So there's nothing wrong with using existing Valkey data structures. In fact, if you don't want to build your own data structures, you can just build the commands that simply wrap the existing data structures. So you will have a list, a sorted set, a hash map, etc. I wanted a little bit more control because think about this. Let's say, and the same problem will exist in a client library, right? Let's say your client library pushes into a list, then for visibility timeout, maybe it pulls it off a list and it stores it somewhere in a sorted set for a period of time. Well, those data structures are available to other Valkey commands. So somebody could connect with Valkey CLI and delete a hash map, and the corresponding key exists in a list. So when the consumer pops an item off a list and says, I would like to process this message, tries to look up the corresponding hash map with actual details for the job execution, and the hash map is not there. So yes, you can use existing data structures. I specifically wanted to control that, and I also wanted to challenge myself a little bit to build some of these advanced data structures. And again, there are other use cases where, for example, Valkey Search will actually take advantage of the documents in existing JSON or just hash maps, and then the Valkey Search stores only indexes. So that's an example of combining the custom and generic data structures.
We have time for one more question. Hari.
Hey, nice demo.
Thank you.
I had a question around, you mentioned at least once delivery.
Yes.
Do you persist it to somewhere to guarantee that?
So if you look at the GitHub page, so at the end of the day, there's still data has to either be saved to disk or replicated. So there's still underlying limitation of the data structure of not data structure of Valkey as a data storage engine. So yeah, but it's really fast. So you can see here that the push and pop are almost as fast as the underlying list and sorted set. However, the memory utilization is not nearly as good. So I probably need to optimize my structs to be more memory efficient.
Okay, I think we're at time.
Feel free to stop by afterwards and ask me any questions. And I'm happy to share the slides and the code later.
Okay,
if anybody
thanks.
wants.
Thanks, Dmitry.